This week we continue to look at annuities. I'm going to do 3 examples of annuities due and then 1 example of a deferred annuity. Now this first example, we have Gerald investing $200 start of every week. The account earns 5.2% interest compounded weekly, does this for 5 years. Now this is an annuity due because he's investing at the start of every week. So it's the start of the payment period. That means annuity due. Now this one's an easier one because the compoundings are weekly and the interest, or the payments, are weekly. So we don't have to adjust I. So I will be 0.052 divided by 52, which is 0.001, and equals 5 times 52, which is 260. And then from here we can go straight to our future value formula. So future value of an annuity due, our payment, our first part of our annuity formula, but now because it's annuity due, we have this extra piece to the formula on the end. And then we can just calculate it, and we get 59,411.67. Now this example, Helen's taken out a $15,000 loan and we're trying to figure out the payments. The loan has interest compounded semi-annually, but she's paying at the start of every month. So the compoundings are different, so we're going to have to find C and find our I2. We have to modify our I, our interest. Now again, it's a start of every month. That means it's an annuity due. So let's get into it. First, we can calculate I. We can calculate C. We can even calculate N here. Remember, N is your number of payments, not your number of compoundings. We have to adjust I so that the compoundings coincide with the payments. Remember to keep all the decimals. Now we have 15,000 equals payment to the negative 36 Now, there's a couple steps you can do here. You could calculate out the right-hand side, then divide the 15,000 by it, or just move everything down so you'd have 15,000 divided by that big square bracket and that little round bracket to equal payment. When you calculate this out, you will get 446.13. Now's a good point to stop the video. Try this calculation and make sure you're getting the same answer as me. This third example, we have Ian, who just took out a loan, but we don't know how much the loan was for. We know his payments, we know his interest, and we know how long. So we have quarterly interest, and we have payments at the start of every 2 weeks. We're going to have to find C and find I2. Now it's the start of every week, so again, it's an annuity due. So we calculate the original I, we calculate our N, which is just 208, and then we need C and our modified I. Now we can find our present value due. calculate it out. And we get over 82,000. Now our last example is what we call a deferred annuity. This is because this Jean has borrowed some money. For the first year, she makes no payments. This is the deferral period. After that first year, then she starts making payments. So we're going to have to do this in 2 steps. First, you calculate the future value of that $7,500 at the end of the deferral period, and then you use that for your annuity calculations. Now we're going to have to calculate I. Our N will be 12 because it's monthly. So future value equals. So again, that's what a loan is worth after 1 year. Now we use that to calculate the annuity payments. Now here, the interest is monthly. That doesn't change. But now she's making payments at the end of every week. It's the end of the week, so it's just a regular annuity, an ordinary annuity, not an annuity due. But we still need to modify and find C and I2. We're also going to need N. Put this into our formula. Calculate it, and we get $82.63 for her payment.